Yo, what's up, calculus students? Mr. Mester coming at you. This is the first homework video I've ever recorded from St. Andrews. So, looking forward to seeing how this comes up. We are reviewing the unit circle, reviewing trigonometry. The key, guys, is to be able to do this stuff quickly. Comes out of nowhere. Boom, what's the sine of 2 pi over 3? You got to be able to know the answer. We don't have time to recreate the unit circle. We don't have time to keep something memorized in our brain. We just got to be able to get the answer as quick as possible and to be able to pull it at any point. You don't know when trigonometry is going to show up in this class, so we just have to be ready for it at any time. Okay. It all starts with understanding radian measurements. Radian measurements, not the easiest thing to remember. So let's remember it's the distance around a unit circle. We use the formula for a circumference. Circumference is 2 times pi times r, but if r is 1, then the circumference is 2 pi. We consider 2 pi to be equivalent to what we humans use as 360 degrees. From there, we can get some just easy radian measurements. I'm going to divide everything by 2, and I get pi is 180 degrees. So halfway around the circle, 180 degrees. I'll divide that by 2, and I get that pi over 2 is 90 degrees. I'll divide this by 3, and I get pi over 6. So like dividing by 3 is the same as multiplying by 1/3. Pi over 6 will be equivalent to 30 degrees. So I'm dividing by 6, which means I'm dividing by like a lot, and I get a small angle measurement. If I come back to here and I divide this by 3, I'll get that pi over 3 is equivalent to 60 degrees. Okay. Now, these are important, guys, to remember. All of the pi over 6s end up being 30 degrees. All the pi over 3s are 60 degrees. All of the pi over 2s are 90 degrees. Good. That's the first thing. The other first thing we need to know is where we start. We like to start at an angle of 0 degrees. 0 degrees being over here to the right, where our initial ray and our terminal ray are both over there. So think about my hands being together. My hands are together. I have a 0 degree measurement or a 0 radian measurement. Then as my hands start to separate in the counterclockwise direction, we are adding angles till we get all the way around the circle. Halfway around the circle, we will get to that halfway point, the 180 degree angle, or the pi radian. So coming around this way, I get to pi, which is 180 degrees. But again, as I continue to travel that way, I will be adding angles. Conversely, if we want to go in the other direction, the clockwise direction, will be subtracting angles. Clockwise direction, we will be subtracting angles. This is going to be very important because when we find where locations of radians are, we like to go off of 0 or pi and either add or subtract 30 degrees or 60 degrees, add or subtract pi over 3 or pi over 6 radians, okay? So we already talked about these first two, and this is what I want you to do. Sorry if you're just like fast forwarding through this. Pi over 3 is equivalent to 60 degrees. I like to just draw this and know that this arc length is pi over 3 radians. Pi over 6 over here creates a 30 degree angle. Great. Pi over 2, 90 degrees. If you want to draw that as 90 degrees, that's great. Pi over 2 is going straight up and down. 3 pi over 2. Here's the first instinct of like starting somewhere and traveling somewhere. Imagine you're at pi. Pi can be written as 2 pi's over 2. It just has like 2 divided by 2 is just 1. It's just looking differently. You can add pi over 2 to 2 pi over 2, and there's 3 pi over 2. What is that adding? Adding 90 degrees to 180 degrees. We don't like to really worry about what the angle measurement is. Rather, we just like the location and the reference angle. So we're good there. We could have also done 2 pi, which is all the way around the circle 360 degrees, and we could have subtracted pi over 2. So I would like to write 4 pi over 2, 2 pi is being 4 pi over 2, and subtracting pi over 2. Cool. And that's how we get 3 pi over 2. We'll do many others like that. For example, 5 pi over 6. The best thing that I do is I start with either pi or 0. What's closer to 5 pi over 6? Pi or 0 or 2 pi? And I know it's like really close to pi. Pi can be written as 6 pi's over 6. Pi can be also written as 3 pi's over 3. So think about this. I could write 5 pi over 6 as 6 pi over 6 minus a pi over 6. And I can do that easily in my head. 6 pi over 6 minus pi over 6 is 5 pi over 6. Well, let's start at pi. Let's remember adding angles goes that direction. Subtracting angles goes this direction. Boom. That puts me here. Now, what is subtracting pi over 6? That's subtracting 30 degrees. So I'm going to be 30 degrees away from 180. I don't care that it's 150 degrees. I just care that this is the location. So the second quadrant. I care that it creates what's called a reference angle of 30 degrees with 180 degrees. 5 pi over 3. Is that close to pi? It can be. You could say it's pi plus 2 pi over 3, but it's closer to 2 pi, which is 6 pi over 3, which is around the entire circle. 6 pi over 3 minus a pi over 3 is 5 pi over 3. So we go all the way around our circle to 6 pi over 3. We then subtract a pi over 3. This would be the direction of subtracting. What is a pi over 3? We remember pi over 3 is 60 degrees. So I will be 60 degrees away from 360. Does that happen to be 300 degrees? Sure. Do I care? No. I care that I'm 60 degrees away from 360. That's what I expect you to do. Okay, I'll start going faster on the other ones. 3 pi over 4. It's 4 pi over 4 minus a pi over 4. I forgot to mention what the pi over 4s are. Take pi over 2 and divide it by 2, and you'll get pi over 4 is 45 degrees. Anything with a pi over 4 will be 45 degrees away from the x-axis. So here is 4 pi over 4. Subtract a pi over 4, 3 pi over 4. 45 degrees away in the second quadrant. Pi is at 180. There it is. We'll talk about the extremes later in the homework. Pi over 3 is 3 pi over 3 plus a pi over 3. Pi over 3 is 60 degrees, so I want to go to 3 pi over 3 and then add 60 degrees. So I'll be right there. It's a little bit exaggerated, but that's okay. 5 pi over 4, 4 pi over 4, plus pi over 4. It's 4 pi over 4. It's the same as 3 pi over 3. It's pi plus counterclockwise plus. Seven pi over 4. I'm going to go all the way around to 8 pi over 4. Subtract a pi over 4. This is a good one. You could either go minus 1 pi over 3 minus 2 pi over 3, or you can go to minus 3 pi over 3 and add a pi over 3. If you went to minus 3 pi over 3, you're still adding in this direction, you'd still end up here, 6 degrees away. Some challenging ones like 7 pi over 3. Well, this would end up being in the first quadrant, 60 degrees away. 13 pi over 4. It's really close to negative 12 pi over 4, but where the heck is negative 12 pi over 4? Negative 12 pi over 4 is negative 3 pi. So this one's a little tricky. Negative 1, negative 2, negative 3 pi. Negative 3 pi ends up being in the same location as pi or negative pi. And then I want to then subtract another pi over 4. Now, again, starting at 0, adding, subtracting, subtracting angles. Subtracting a pi over 4 puts us right there. Trick. $17 pi over 6 is very close to 18 pi over 6. How did I pick 18 pi over 6? It's like, it creates a whole number. Like, why didn't I pick 14 pi over 4? Because that doesn't divide out nicely. But I know 12 pi over 4 creates 3. Why did I pick 18 pi over 6? Because it creates 3 as well. So we're going from 0. This is 1 pi. This is 2 pi. This is also 3 pi. And then subtract a pi over 6. So right here, many of you are working a lot quicker through this than I do, and I'm okay with that. The key is to be able to kind of do this in our brain so that we understand quadrant, reference angle, and then triangle. Negative 5 pi over 2, I'll start at 0. You can either go negative 1, 2, 3, 4, 5 pi over 2. There's that. Or you can go to negative 4 pi over 2, which is negative 2 pi. And then you subtract another pi over 2 to get you negative 5 pi over 2. 90 degrees. And that's it. Okay, so that's step 1. Let me just cool off a little bit and we'll start doing the other parts. Cool. Now, the next thing we do, and this is why we like to use the unit circle, is we will create triangles whose hypotenuses are 1. These are triangles that we've known since geometry, and they are triangles that are the easiest triangles to work with when we're using trigonometry of these angle measurements. So if I asked you to do the cosine of pi over 4, this is what I would do in my head. First, understand pi over 4. Second, understand the triangle that's created that has an hypotenuse of 1. This is why it's called like the unit circle, the radius of 1. And the side lengths that we have in this quadrant. Now, you can go ahead and write out both of the side lengths. However, I actually don't need this one because I know I'm asked for the cosine. I know in SOHCAHTOA, the ka in SOHCAHTOA is adjacent over hypotenuse. Well, the great thing about the unit circle is the h is not necessary because it's 1 and you divide by 1 and you just get whatever you started with. Cosine always concerns itself with the adjacent side length divided by the hypotenuse. In the unit circle, cosine just worries about the adjacent side. So we get this angle measurement, this pi over 4, creates this 45-degree triangle in this quadrant. We have our ratio. It's not memorized, it's just understood. Pi over 3. Okay, pi over 3 creates that 60-degree reference angle. It's in the first quadrant, remembering that this is an angle of 0. So we're in the first quadrant. We create a 60-degree angle, and then we break out our friend Mr. 30, 60, 90 triangle, whose hypotenuse is 1. There's a short side and a long side. The long side is opposite the big angle. This is the 60-degree angle. This must be the long side. There's the short side opposite the shorter angle. Which side is which? Well, it's either root 3 over 2 or it's 1/2. Root 3 is bigger than 1. Root 3 is somewhere between 1 and 2. It's like 1.7. So root 3 divided by 2 is bigger than 1/2. Keep this in your brain, that root 3 divided by 2 being bigger than 1/2 means this is your bigger side. Now, I actually could write down both sides, but I only care about the opposite side because sine is so in SOHCAHTOA. However, I don't care about the h because the hypotenuse is 1, and when you divide by 1, nothing happens. So I just care about this opposite side length. It just so happens this adjacent side length is 1/2, but I don't really care about it. This is the opposite to this reference angle. That's how I get root 3 over 2. You can get so good at this that you can do it in your head. What we don't want to do is have to have the entire unit circle memorized, then write it down for every single quiz that we have this entire year, because we may or may not have trigonometry on a certain quiz. Tangent, a little bit more difficult because it's the TOA, which means it's opposite and adjacent, which means the fact that the hypotenuse is 1 does not help us. The opposite is the shorter side length. The adjacent is the longer side length here. Let's just remember how to divide fractions. Dividing is the same as multiplying by the reciprocal. We are allowed to keep our answers like this on free response in this class. However, we need to be prepared to what's called rationalize, which is just like formalize our answer. Just goes back to the day when we had to do computations by hand. It is a lot easier to divide by 3 than it is to divide by root 3. Okay? Opposite over adjacent TOA. Now let's move out of the first quadrant. Let's go to 5 pi over 6. Angle measurement, 6 pi over 6 minus a pi over 6 puts me in the second quadrant, 30 degrees away. Then sine I feel like my computer's overheating right now. Okay, sine deals with the opposite over hypotenuse. I don't care about the hypotenuse, it's because it's 1. Now, be careful. This length would be 1/2. If we wanted to deal with the adjacent length, we need to know that it's negative root 3 over 2 because we're moving to the left on like an XY axis. So we don't need to worry about the adjacent. It's just the opposite. That's why we get an answer of positive 1/2. 4 pi over 3, 3 pi over 3 plus pi over 3 puts us here in the third quadrant, creating a tall 30, 60, 90 triangle. Let me do a better job here. Cosine just deals with the adjacent, which is the horizontal length. And it's always going to be of this reference angle. I know 4 pi over 3 is the same as 240, 180 plus 60. But there's a theorem in trigonometry that says the trig function of an obtuse angle is equivalent to the trig function of the reference angle with the x-axis. So like we don't have to worry about the fact that this is like obtuse or even like greater than 180. They're equivalent. We just have to worry about the triangle it references in the correct quadrant. So here, since it's cosine, I only worry about this side. Since I'm moving to the left on the x-axis, we're good. If I were to care about the opposite side length, I would need to know that that is the longer side length, negative root 3 over 2. Tangent of 7 pi over 6. Here's 6 pi over 6. Add a pi over 6. Here's 7 pi over 6. Here is the triangle that's created. Tangent, opposite over adjacent, opposite, adjacent. Opposite will always be the vertical side length. Adjacent will be the horizontal. Opposite over adjacent. Dividing is the same as multiplying by the reciprocal. A negative times a negative is a positive. The 2's cancel. 2 divided by 2 is 1. This is acceptable for your quiz next class. This is an answer you need to be prepared to provide for like a multiple choice question. It's more formalized, but for your quiz, I will accept this. I will accept this. So there's that. 11 pi over 6. I'm going to go all the way around to 12 pi over 6 and then subtract a pi over 6. Subtract 30 degrees. Bigger side, smaller side, cosine, adjacent over hypotenuse. I don't care about the hypotenuse because it's 1. This is why we use the unit circle. I don't care about the opposite, and I should have written that as negative because I'm going down. I just care about the adjacent, so I just get that. Sine 2 pi over 3. 3 pi over 3 minus a pi over 3. 60 degrees. Sine is the opposite. I'm going up on the XY axis. If you consider that, that's why that's that. 5 pi over 3. I know where 6 pi over 3 is. I will subtract a pi over 3, subtracting going clockwise. That's 60 degrees. Tangent, opposite over adjacent. I'm going down. I'm in the 4th quadrant. So there's the longer side. That's negative. Here's the shorter side. That's the adjacent. That's positive. Guys, you could get to a spot where you're doing this in your head. You can get to a spot where you do this on paper. What you shouldn't be doing is copying this down. Opposite is always the vertical. Adjacent is always the horizontal in this configuration when we're talking about these angle measurements. And there's that. Okay, now we start looking at reciprocal functions. So secants, cosecants, tangents, cotangents, then we'll get into the extremes. I hope you don't think that this homework is a lot. It's just like lots of practice that you could do faster than I do right now. If you're doing this like without showing any work, you're good. Just get the right answers, okay? I'm just showing you all the steps. So, cosecant is the reciprocal of sine. So I need to find the sine of pi over 4 and then flip it. Pi over 4 is that 45-degree angle. We have that isosceles triangle where the side lengths are the same. You should have remembered that the side lengths of this 45, 45, 90 with a hypotenuse 1 is root 2 over 2. So I want to flip root 2 over 2, which is 2 over root 2, which is acceptable, but you should be able to see that this is equivalent to root 2. How do you get that? There's so many ways. You could actually write this as root 2 times root 2 over root 2, and then boom, you get your answer root 2. You could also rationalize, and you get that, you get 2 root 2 over 2. And then that simplifies to be root 2. Lots of different things you can do. Okay. Pi over 3, secant. Here's pi over 3, 60-degree angle, hypotenuse 1. Don't have to write that, but I'm doing it. Secant's the reciprocal of cosine. So we write down the cosine, and I want to find the cosine of pi over 3 and flip it. Cosine of pi over 3 is a half, so I want to take a half and flip it. You could also just like say the cosine of pi over 3 is a half. Therefore, my answer is 2. Cotangents, the best thing to do is to not find the tangent and then flip it. It's just to find the cotangent. If tangent's opposite over adjacent, then cotangent must be adjacent over opposite. So we go to pi over 6 and we do adjacent over opposite. The 2. Dividing, same as multiplying by the reciprocal. All right, let's find the cosine of 5 pi over 6 and then flip it. Try that. 6, go to 6 pi over 6, subtract a pi over 6. Cosine is the adjacent. There's the cosine of 5 pi over 6 right there. Flip it. Rationalize it. There's my answer. And again, I will accept this answer on your quiz, but for a test, you need to be prepared to get that answer. Let's do adjacent over opposite, 4 pi over 3. Here's 3 pi over 3. Add 60 degrees. Here's 4 pi over 3. Tangent's opposite over adjacent. Cotangent is adjacent over opposite. Negatives divided by negatives, positives. I can do 1/2 times 2 over root 3. Positive, which is root 3 over 3. I will accept either of those answers. 7 pi over 6, 6 pi over 6 plus 30 degrees. Cosecant the reciprocal of sine. Find the sine of 7 pi over 6 and then flip it. There's a sine, there's flipped. I'm going to do these in my head. See if you can follow along what I'm doing. Okay, 12 pi over 6, subtract pi over 6, I got a 30-degree angle. Cotangent's adjacent. Adjacent's the longer side because I got a short 30, 60, 90 versus a tall. So adjacent is root 3 over 2. Opposite is a half. Root 3 over 2 divided by a half is root 3 over 2 times 2 over 1. It's root 3. I have a negative a half, so this needs to be negative root 3. 2 pi over 3, I'm going to go all the way over to pi. I'm going to subtract a pi over 3. Secant's the reciprocal of cosine. Cosine is this negative a half because it's the tall one. Cosine's the shorter. So I'm going to flip that. I'm going to get negative 2. I literally have to do this in my brain if I have this problem. I don't have any of these memorized. This is all just like thinking. Sine of 5 pi over 3. I'm in the fourth quadrant because I got all the way around to 6 pi over 3. Subtract a pi over 3. That's 60 degrees. The sine is going to be root 3 over 2, but it's negative because I'm going down. I'm going to flip it, and I got negative 2 over root 3, which is equivalent to negative 2 root 3 over 3 after rationalizing. Let's just do that on picture quickly. 11 pi over 6, 30 degrees, bam. negative a half, root 3 over 2, adjacent over opposite. Bam. 2 pi over 3, go to 3 pi over 3 and subtract 60 degrees, tall 30, 60, 90, short side, long side. Cosine, negative a half, flip it. 5 pi over 3, go all the way around to 6 pi over 3, subtract a pi over 3, 5 pi over 3. I have that and that. Sine is that flipped. Cool. Okay, now we get to the extremes. The extremes are like on the X or the Y axis. Let me cool off a little bit and then we'll do this. All right, so for the extremes, here's what we just have to keep in mind. And this is a little tricky because it's like, how can we have a ratio if we don't have a triangle? If trigonometry is all about triangles, what happens if I don't see a triangle and I'm at pi over 2? Well, it turns out there is, just like one of the side lengths is 0. That's hard to explain, or to think about. So here's what we go with. We know that sine's ratio is always opposite over hypotenuse. And since the hypotenuse in the unit circle is always 1, it's always going to be the opposite side. Well, the opposite side, when our triangles are always oriented in this, coordinate system, starting at 0, standard position, the opposite always ends up being the vertical displacement, as in like how much we go up or down. Up being positive, down being negative. The cosine of the angle will always be adjacent over hypotenuse. Since the hypotenuse is always 1 in the unit circle, we just worry about the adjacent side length. And the adjacent side length is always going to be the horizontal displacement. Now, thinking about this being the unit circle where the hypotenuse is always 1, we are going to be going in the direction, but only a distance of 1 away, because we are inside this circle of radius 1. So, pi over 2, we know as being like a 90-degree reference angle. Well, we end up like 1 away, like coming out of the origin. We get to that unit circle 1 away. How far did we travel? Well, we traveled up what? Did we go to the left or to the right at all? No, I did not go to the left. I did not go to the right. Just went up. Well, here we have a triangle whose opposite side is 1, whose hypotenuse is still 1, but whose adjacent side is 0. Since the horizontal distance, since the adjacent displacement, since the horizontal displacement is 0, the cosine of pi over 2 is 0. Now, if I ask you what's the sine of pi over 2, you'd say it's 1. Why? Because we go up 1. Sine of 3 pi over 2. Well, 1, 2, 3 pi over 2, or 5 pi over 2 minus a pi over 2 puts us down here, 90 degrees away. How did we travel to that point on the unit circle? Well, we didn't go to the left or to the right at all. We went down 1. Since we go down 1, we're going in the negative y direction. The sine of 3 pi over 2 is negative 1. If I asked you what's the cosine of 3 pi over 2, well, you'd say just like the cosine of pi over 2, it's 0. Cool. Now, tangent being opposite over adjacent would be vertical over horizontal. So let's think about the tangent of pi. Here's pi. I get over here. I only go a unit of 1 away so that we have this hypotenuse of 1, this unit circle. And I go to the left 1. I do not go up or down at all. I'm just going to the left 1 from the origin. This is the adjacent. This is the horizontal. This is the opposite. This is the vertical. Opposite over adjacent. Is this 0? Is this undefined? It's important for you guys to know. I always like to confirm things using just a simple example. What's 8 divided by 2? It's 4. How did I get that? Well, you could think 2 times 4 is 8. 0 divided by -1 is 0. Does that work? -1 times 0 is 0? Yes. So, like, that's your backup. I'll show you how that works if it's flipped. Okay, the sine of 2 pi. 2 pi is all the way around here. How do you get all the way around here? You go to the right one. You do not go up or down at all. So the sine of 2 pi is 0. Sine being the opposite. This is the opposite. This is the adjacent. The cosine of 0. Well, here's the angle of 0. There is an angle. It's over there to the right. That's the angle of 0. How do you get to that location? You go to the right one. You do not go up or down at all. So it's the same as this. Cosine being adjacent, this is the one that screws everybody else up. The cosine of 0 is 1. Many of you memorize it's this quadrant on the unit circle, but like, I don't know. I like to stick with SOHCAHTOA. 3 pi over 2 is down 1. Opposite would be that down 1. Adjacent would be the over to the left and right 0. Now, let's think about that. 8 divided by 2 is 4. 2 times 4 is 8. -1 divided by 0 is 0. Well, it's 0 times 0, -1. Nope. Is 0 times anything -1? Nope. This is how I remember that dividing by 0 just can't be done. How many times does 0 go into -1? It just can't be done. Okay. Let's finish strong here. I will do this quickly. Pi over here. I go to the left 1. I don't go up or down at all. The cosine of pi is -1. 9 pi over 2. 8 pi over 2 is 4 pi. So 4 pi plus a pi over 2 is 9 pi over 2. That's right there. I go up 1. Sine is the verticals, not the horizontal, so I get 1. Opposite over adjacent. The opposite is the up and down. If I'm at 0, I'm not up or down at all. I am to the right 1. This would be the opposite 0. This would be the adjacent 1. So I'm going to go opposite over adjacent. That's 0. Reciprocals. Let's find the sine of pi over 2 and flip it. Sine of pi over 2 is 1. If you want to flip it, still 1. Let's find the adjacent over the opposite of 3 pi over 2. The adjacent is 0. The opposite, the vertical, is -1. Adjacent over opposite, 0. Secant of pi, I know the cosine of pi is -1. If I flip -1, put a 1 under it, flip it, you still get -1. How do I know the cosine of pi? Like, here's pi. I go to the left 1. I do not go up or down. So the horizontal, the adjacent, is -1. If you're not getting this, come in. I'll give you more practice. Cosine of 2 pi, flipped. I know the cosine of 2 pi is 1 because I go to the right 1, but I don't go up or down at all. Flipped is 1. Adjacent over opposite of 0. The adjacent is 1. The opposite is 0. Adjacent, opposite. Adjacent over opposite. Can you divide by 0? No, you can't. It's not defined. Sine of 3 pi over 2 is -1. I go down 1 at 3 pi over 2. Flip it. You still get -1. Here's a good one. What is the sine of pi? Well, here's pi. I don't go up or down at all when I go over to pi. So the sine of pi is 0. What happens when you flip 0? Well, think about putting a 1 underneath anything and then flipping that. It becomes 1 over 0, which is undefined. Another way to think about it is sine of an angle is opposite over hypotenuse. That means the cosecant of the angle will be hypotenuse over opposite. The hypotenuse is always 1. The opposite is 0. That's how it works out. Why the cosecant of pi works out that way. A lot of people think if you flip 0, you get 0, but it's not true. If you flip 0, it becomes undefined. Oof. I feel like we did 8 pi over 2. 8 pi over 2 is like 4 pi. That's going to be over there at 0. Like 1, 2, 3, 4 pi. Add a pi over 2. We got adjacent. If we go straight up here, adjacent is 0. Opposite is 1. Adjacent over opposite. And then cosine of 0 is 1. Flipped is 1. Okay. I don't know. I feel like I went a little bit fast through that, but I feel like you guys are probably more prepared to go fast through that. I showed you all of the work. You do not need to show the work. You got to get the right answer. If you can't get the right answer, you need to show the work so that you get the right answer. We cannot have the unit circle memorized and then just copy it down for every single thing we do in this class. Please be ready to just pull it out of your brain whenever it is asked for. We can't just go off of memory in calculus. There's too many things to memorize to just like try to memorize how to do everything. It's not going to work out for you. Don't memorize, understand. That's going to be my key to my lesson tomorrow. If you are going off of memory, you're going to struggle in this class. Understand. All right? Peace.